Hello everyone. I'm going to have a quick overview of configurations that will go for bringing up a VSA Secure Access platform. So I'm going to assume there's going to be an existing setup where a new tenant is going to be deployed. So I'll go over the configurations accordingly. So the first things that you will need to do is on the existing workflow that you will have under organizations, you will create a new tenant. And let me show you what I did for this particular case. So I just onboarded a new tenant called VSA demo LDAP. I made sure I added the analytics cluster and added the user support, the supported user roles. And then I just redeployed. So once you actually do that, you will be able to onboard a new tenant using this workflow. Then under template, you go for the template and look at the existing template. Under the existing template, you have to add the organization that you're going to be onboarding. In this particular case, I have added the VSA demo LDAP as the new tenant that will be pushed to the same hub device, which is acting as the VSA Edge gateway. So here you can see that the Versa hub device has been already onboarded as hub controller. So there you would be able to do something similar using just a hub, but we suggest hub controller because it actually provides additional functionality that is coming up in the next release. Under interfaces, just make sure you have the appropriate WAN interfaces selected already. I mean, because it's an existing hub device, the WAN interfaces would be pre-selected, hopefully. But on the LAN side, though, I have the LAN demo LDAP as a new network that I'm adding for the interface VNI03. In this particular case, I just put it as static, but because this hub device is not actually having any LAN side traffic or subnet that needs to be accessed, this is going to be a dummy interface. Under routing, you will not need to do anything, but under tunnels though, you need to make sure you have for the LAN VR, for the tenant, or traffic coming in from the edge client to come into the device, you might be able to have to go out to internet. So you have to have the split tunnel enabled for that and the appropriate internet interfaces added for DIA. So under site-to-site tunnel, you would probably have to, you would be able to create a tunnel from the Versa Secure Cloud Gateway to a third-party network. So you use that to create access from the secure access from the secure access client all the way to your data center network, for example. So the way you do it here is you enter a name here, for example, to DC. Peer type, if you're connecting to an Azure vWAN or a Zscaler, you would pick appropriate selections from the dropdown. This particular case, I would rather just do an unmanaged. I would want to select the LAN network for which this site-to-site tunnel is applicable, and the LAN VR it is part of. And if I have an existing VPN profile, I will select that. Otherwise, I could select a new one, create a name, VPN profile name, for example, to DC for demo LAN. And I would pick the appropriate IPSec transform set, let's say AES-246, and an IPSec transform set. And the number of tunnels, one is good. If you want to have redundant tunnels, you can also select 2 tunnels using this workflow. BGP you can enable so that the appropriate subnets are exchanged over this particular tunnel. The primary tunnel peer key, PSK key, as well as the identifier identity, you can either fill in or later do it using the bind data values. You could select route-based or policy-based. I'll leave it to route-based for now. So once you click on OK, this particular demo VPN profile is already will be created. And you then continue to the next screen, inbound NAT, where nothing needs to be selected. Under services, you might want to make sure if you want next-gen firewall to be selected, pick that. Without next-gen firewall or a stateful firewall, you will not get security services. So it is better to choose one of them. According to that, you will be able to provide additional security functions to the Versa Secure client. So that's pretty much what you need to do to change the existing hub template. You would click on recreate so that it will create the updated, it'll onboard the new tenant on the template that you already have. So once that is done, you would go and make changes to the template that we just created. The first thing that you need to do here under the template is under service node, under organization, under system domain name servers, you would add the domain name, domain name under routing instance, for example, IX transport. I want to be able to add a domain name server, a DNS server, and choose the source internet, no source network appropriately, so that the DNS queries from the system could actually go out using this particular setting. Under service node group, which is under others and service nodes, under service node groups, under default SNG, you might want to make sure the secure access is already available as well. If not, make sure that is added. The next thing that you would probably have to do is under organization, you could click on the organization under limits, click on the tenant that you are added. Under services, make sure secure SD-WAN is also available here. So here you could click on plus mark and add secure access. So that secure access is part of your template for that particular tenant. The next thing that you would probably want to do is add certificates. So for now, I will actually push this particular configuration changes to the hub template, to the hub device, and then make some changes directly on the device. You could actually prefer to do either way, but especially for certificates, I would rather do it at the device directly. So for that reason, I'm going to go to the device here. Under the hub, you could actually go to objects and go to custom objects under keys, CH chains, and CH certificate. These are the ones that the screens that you would use. Under appliance, you need to import the key file for using which you will be generating the key for the certificate. So there is actually a separate procedure under wiki.versanetworks.com. You would actually be able to look for a secure access VPN gateway configuration under that hierarchy. You will actually be able to go over the configuration options that will help you create these certificates. So I'm going to skip that portion. I will actually show that under a different video, but here I will have to probably skip to the next setup here under SNAT. Under objects again, you would want to go under SNAT pool and create a source NAT pool for the demo tenant that you are working with. So here the SNAT pool needs to be created so that any traffic that needs to be originating from this particular tenant going to the internet is using this particular SNAT pool configuration to go out. So this is actually really required, especially for DNS-based queries going out of this particular tenant to any entity outside to the internet. Once the SNAT pool is provided, you will go to the cloud profiles under the same objects hierarchy and create a cloud profile for OTP. So this is the profile that is required for the OTP generation. So the OTP server is actually under this particular IP address. So this is the one that is going to help the portal to automatically take the OTP that is generated from the device to be sent to the user over an SMS service. So you actually have to create the OTP cloud profile under the cloud profiles hierarchy here. Then you would have to go under authentication profiles, under the services secure access, under servers. Actually, sorry. The next thing that you might want to do is create the authentication profile under the objects. So under objects connectors, you would go, actually under connectors, you would go to users and groups, and under LDAP, you can create a LDAP server profile. So here I have already pre-created it, but you can look through the configuration options here. So I named my authentication server, the LDAP server, as Azure AD, and provided the Active Directory as a server type. The bind DN, look, the user, email address and the bind password is provided here with the appropriate timeout values, the bind timeout and the search timeout. The domain name is VSA-networks.com. That is the one that is serves, is the domain for which the Active Directory is serving the user database. And this particular information based DN information is really critical for it to translate the appropriate user information and the group information back into our portal. So you might want to copy down the same thing here. So OU equal to AADDC space users is under OU. Organization user, that's what it actually basically stands for. DC is the domain controller, it's Versa Networks, and DC equal to com is something that you want to push for under base DN. And then in this particular model, I'm having my LDAP server listening on SSL. So I'm using the SSL mode as LDAP-S, and the use SSL is enabled. The CS certificate needs to be selected as default. And during the certificate creation process, we would also make sure the default certificate is also present for that particular tenant. So here under the server configuration, I have provided the IP address of the server on port 636, which is the port number which the Azure AD server listens for SSL-based transactions. I selected the appropriate routing instance using which the Versa Cloud Access Server will be able to reach the LDAP server and the appropriate FQDN to which it is going to reach out to. If you were actually, in fact, using a local database instead of LDAP, then under local database, you would be able to add the appropriate users and the groups to which they belong to. So in this particular case, I have no groups configured, but you can just create the user accounts here under this tab here, provide the username and the password and the appropriate first name, email address, and so on. If you provide a phone number, it'll be helpful to get two-factor authentication for that user. Otherwise, there is no means for the OTP server to be able to send an OTP passcode when the user logs in. Next thing will be the authenticator profile. So under authenticator profile, you would create the profile for the one-time password server. So in this particular case, in the current release 20.2.2, we support REST-based authenticator service. So I selected that type under authenticator type, and the one-time password that we provide options for are over mobile and email address. So under in 20.2.2, we currently support the mobile-based OTP delivery. So I selected that, and the OTP format as numeric today. And cloud profile is something that we just created under the objects so that it knows what is the actual OTP cloud server to reach out to, and the number of the length of the OTP password to be generated, and how long it's going to live. It's all provided here. And once you create the authenticator profile, you'll be able to put together everything under authentication profile. So you create a new authentication profile. In this particular case, let's say the LDAP auth profile. Here is where you select the LDAP profile, the AD server that we created earlier, and also call the appropriate authenticator profile underneath, so that any LDAP based authentication will also, in addition to the username and password that the LDAP profile will require, it also trigger an SMS generation for that particular user. So here you need to make a note that if the LDAP server does not contain the mobile number for the particular user, then there is no way for the user to get the SMS. So you need to make sure, choose the authenticator profile as OTP only if all the user in your Azure AD account has the mobile numbers attached to it. So rest of them, it's concurrent login here. Number one will actually note that only one simultaneous user, only one login is allowed simultaneously. So it will basically have a kind of an enforcement that the user will not be able to simultaneously use more than one device to access a network using the same login. Okay. So this is all the objects that are required to now go and configure the required profiles for IPSec and for VSA. So under services, you go to under IPSec VPN profiles. You create the IPSec VPN profiles for remote access clients to terminate their IPSec channels to the VSA gateway. So here I have created two profiles, one for all traffic and one for intranet. The difference between the two is on all traffic, all the traffic from the VSA client would come into the gateway to exit to internet or intranet. So it doesn't have a separation between internet-bound traffic and internet-bound traffic. So all the traffic from the VSA client will be coming into the gateway, will be backcalled to the gateway. And in the intranet profile, only traffic coming in to the data center bound applications or subnets will ride over the tunnel, and all the other rest of the traffic would be DIA or split tunnel to internet. So here under IPSec profile, all traffic, you can see that I created the VPN type as remote access server, and the tunnel initiate mode is based on the traffic. And here you might want to create an unique ID for the RAS under the RAS ID. And this is something that will be used for the VSA server to map a user coming in to the gateway to which profile that it needs to be chosen appropriately. So for that reason, you might want to have a specific RAS ID, which is unique to that particular profile created here or specified here. The routing instance is Internet Transport VR because traffic is actually coming in through your WAN interface. Under the options of route based or policy based, it's always route based because we want to make sure traffic based or prefix based routing happens. So we pick the selection as route based, and under tunnel routing instance, you might want to have LAN VR because we are going to actually terminate the tunnel directly into the LAN interface or the LAN routing instance. Under address pool, you would then provide the address range which will be the pool from which the addresses will be allocated to the remote access client. I provided here a mask as well as a /24, and the accessible subnets is the configuration to see to let the remote access client be able to access this particular subnet while they come over the tunnel. So in this particular case, it is implied that the remote access client is able to access the 10/8 network in the data center. And the server name here, Versa, it doesn't really imply anything, but it's good to provide a server name here. Under name server, you might want to provide the name DNS servers, which will then be used to do the DNS query, DNS resolution for traffic coming into the intranet specifically. And the domain names would be automatically appended for anything that you ping. For example, if you ping server 1, so the DNS resolver needs to know under which domain it is trying to resolve that particular name. So for that reason, the domain names provided here will be helpful to do the proper resolution. Under IKE tab, it's basically one major, the version V2 is what we support. The auth domain is split tunnel, and rekey timeout by default is 8 hours. So one major difference from earlier versions that now 20.2.2 versions and above will support is having multiple transform sets. So earlier we would only provide a single transform set. So if the client or the other side does not match the transform set that is provided, it will not be able to bring up a tunnel. So having a sequence or a set of transform sets will help the client to negotiate whichever transform set that they need so that they can pick from the list that is provided here. So as you know, Versa supports up to SHA-512 and AES encryption algorithm all the way to AES 256 and DH group to be up to group 2026. Under local auth, you might want to choose it based on the certificates that we had loaded up earlier. So the idea is the certificates is the mechanism that the client will use to validate the server. So you might want to create the certificate names, certificates based on the CA signed certificate. And so in this particular case, under local auth, you will actually be able to choose the certificates using which the client will authenticate the server. Under the certificate name, you provide the certificate that you had previously uploaded, and under CA name, the CA certificate will be provided here as well. So the idea is the root certificate will actually sign the intermediate certificate, and the intermediate CA certificate will be signing the end entity certificate. So the CA chain here indicates the intermediate certificate that is actually the one that is signing the certificate, which is belonging to the server. And under IPSec, we select the tunnel mode, and rest of all is all kind of default. Here again, we provide now an option to provide multiple transform sets from which the client can choose one among which to default on. The same thing, I had created another profile for intranet. So the only change here is under address pool. The accessible subnets is pretty much the same actually. So we just created two separate profiles, one for intranet and one for intranet. And you will be able to actually provide a different address range from which the traffic needs to be selected from. One second. Okay, So we saw the profile for intranet right now. Now we will actually see the profile for all traffic. So the difference between the two, here you can see that I have a separate unique RAS ID, the remote access server ID. You might want to make sure the remote access server ID is different between the different profiles so that the appropriate profile can be called or mapped when you create your client profiles. Under address pool, you can see that for all traffic, I have the accessible subnets as default. So which basically means any traffic destined to anywhere for this particular client using this profile would go over the tunnel. Whereas on the other, just to remind you again, on the intranet profile, the address pool had a specific subnet so that only the traffic destined to this particular subnet was actually going over that particular tunnel. So rest of all configuration is pretty similar. The address pool though would be a different range from which the address will be allocated when the remote access client connects to this server. Okay. So now that we have created the VPN profiles, we go under secure access configuration. First thing to do is route configuration. So this is basically telling you all the different subnets or routes or prefixes that will be applicable for different profiles. So you can create a list of all prefixes that can be then mapped to the VPN profile, which will be allocated or pushed to the client device. DNS resolver is another object that we create to provide connectivity to say a specific client for a specific user can use a set of DNS servers. Under servers, you create, let me actually do the services first. Under services, you create two different profiles, one for the portal and one for the gateway. Let's start with the portal. Under portal, you can see that the URI here is kind of unique. Remember to create one for the portal and one for gateway, like I said earlier. But even if you have multiple gateway and portal profiles, you need to make sure the URI information is unique. Under service type for the portal, I selected, of course, the portal and left the secure access profile to default servers. Under authentication profile, choose the type of authentication that you want to use when the user or the client connects to this particular tenant. So in my use case here, I'm choosing the LDAP auth profile. These parameters here could be ignored. They're going to be hidden from future in the future releases. Under gateway options, I have again created a unique URI called gateway. Service type is gateway. And in this particular case, I have the authentication profile and the authenticator profile mapped to this particular user so that when the user comes in, the appropriate authentication mechanism will be chosen. Once again, the parameters that you see in the bottom panel under parameters, subpanel, all of these values could be ignored. In the future release, this will be taken out from the UI. Under servers, you create two different profiles, one for the intranet and one for allnet. The intranet is be the split tunnel case. Setup, you can also set certain priority so that when the profiles are pushed to the client, it will appear in a certain order. And here you can see that the IPSec profile ID is matching the RAS ID that I had used in the IPSec profile configuration. And this is how when the profile gets pushed to the client and the client chooses his profile to connect, it knows which of the few VPN profiles to use to validate that particular client. Here, the host ID will be an FQDN, and this is the one the client will use to reach out to the gateway. And you can see that everything after this URL, the last part, the gateway, is the one that is matching the URI that you created under services. So you need to make sure this gateway here matches the name that you provided under the URI for that gateway. And I have the CA certificate as an option for the server to validate, for the client to validate the server. So under CA certificate, I'm choosing the CA appropriate CA certificate here. Under traffic steering option, I'm saying that this profile will be a split tunnel profile and have the private IP addresses as the routes that the clients can reach. And similarly, under DNS resolver, I'm providing the versionetworks.com, the object that we created for under DNS resolver, so that the information is passed on as a profile to the client. Under IPSec, we are saying it has to choose EAP and client auth EAP type to be MS-CHAP v2. These are the only options that we support today, so that it is unique or similar for both Mac OS as well as Windows. So here, rest of all configuration under PFS group and IKE transform and IPSec transform is something that will mandate the client to choose this appropriate transform set when this particular profile is chosen. This is how the IT administrator can mandate a certain encryption standard for their enterprise. The tunnel authentication method, the certificate is choosing the appropriate CA certificate so that the client would know how to validate the server that it connects to. The similar option under FMT AllNet, I have the priority set as 60 and the IPSec profile as force tunnel, which basically matches to the other VPN profile that we had created, which will take all traffic destined to both intranet and internet over the tunnel. Here again, the URL information is the same because the same gateway is going to be reached out. And the host information matches to the FQDN, which will resolve to the actual gateway that we are connecting to. Here again, the CA certificate is same as earlier. Under traffic steering, I don't actually have to specify split tunnel, so I'm going to unselect that. Here under, you can see that under routes, I have default route as the option selected under the dropdown. This will basically map to the 0.0.0.0/8 subnet, which basically means any traffic destined to any destination will be choosing the tunnel to go over. And the DNS resolver, same as earlier, versionetworks.com. And IPSec profile, once again, we can choose the appropriate transform sets to standardize what transform set to use for traffic going over this particular tunnel. The last part of the configuration here is under profiles, under default servers. You might want to kind of map everything together. So under split tunnel, I am choosing the routes as private IP, the resolver as versionetworks.com, and servers as FMT AllNet and intranet. So the split tunnel option here basically specifies that the client knows that it can, if needed, can do a split tunnel, even though the profile scan will appropriately show, will know what kind of subnets it reaches if it has a split tunnel enabled. But having the to activate the split tunnel configuration, you need to select the split tunnel checkbox here. And once again, IKE and IPSec transform sets and client controls provide a way for the user, the IT administrator, to let the user know what the IKE and IPSec standards are and the defaults are. And under client controls, it basically tells whether user can add a custom gateway or make changes to the configuration on the profile. If this, for example, if the edit gateway option is not checked, the user will not be able to make changes directly on the device. So it gives an additional control for the IT administrator to make sure the user who is not supposed to make any changes will not be able to do so. Okay, the remember credential option is also kind of useful for that every time the user uses the profile, they do not have to enter their password. So that's pretty much what we have to cover the VSA configuration. Let's do a quick demo to complete this. Thank you.